Recording in progress.
Can we start?
Yes, sir. Good morning, all. Am I audible?
Yeah.
Okay.
Hello, sir.
Agila ma'am, can you please stop that screen sharing? Agila ma'am?
Good morning, all. So, shall we start the session? Good morning, all.
Good morning, sir.
Good morning. A warm greeting from Sri Saraswati Tyagaraja College, Pollachi, Department of Computing Science, for the 6-day faculty development program on emerging trends in contemporary technologies. First and foremost, I would like to thank our management and principal sir for accepting our proposal. Next, I would like to welcome our resource person, Mr. Prasad Balakrishnan, R&D Head HPC Hewlett Packard Enterprise, Bengaluru, for accepting our invitation and act as a resource person for this first day program. Next, I would like to welcome our backbone of computing science stream, our director, Dr. A. Abdul Rasid sir. Next, I would like to welcome our HOD, PCs, and faculties of our computing science stream. Then I would like to welcome all our participants from other departments and from various institutions. Once again, I welcome you all for this FDP, and I wish this to be a great success. Thank you. Now I hand over the session to our resource person.
Hey, thanks.
Mr.
Can you enable
Balakrishnan,
screen
sir.
share for me? The host has disabled participants screen sharing. Can you enable screen share? Can you guys hear me?
Yes, sir. Yes, sir. It's in progress, sir.
Just right click on the participant and just make enable screen share. Yep, I got it. Thanks.
Thank you, sir.
Let me know if you guys can see my screen. Can you see my screen?
Yes, sir. Prasad, sir, with your permission, only 1 minute.
Sure.
Okay. Nice to seeing you virtually, though we have been separated geographically and connected virtually. And nice to see you. Hopefully, we will meet in person very soon, as soon as possible. For the sake of the information to all the participants as well as to the speaker of this particular session, I would like to share that we have the registration from 24 states across the nation and 8 countries over the globe. We have got 825 registrations, and we have also shared the YouTube link to the participants. So some of the participants would probably, join in this Zoom platform, and others also would like to, attend this particular FTP in YouTube. So this is for the sake of the participants as well as to the speaker of this particular session. So with this small note, I think the participants would have a fruitful learning by attending this particular faculty development program. With this small introduction, I hand over the session to Prasad Balakrishnan, sir. Thank you so much, sir.
Thank you, sir. Good morning, all. So we'll keep this interactive. It's going to be a long, really long session. So we'll try to keep it as interactive as possible. It's a small disclaimer. I am not an expert in anything. I'm trying to be good in what I try to do. So if there are things that I don't know, we can search it together. We can find out answers together. We'll keep it as interactive as possible. The topic that was given to me was the Internet of Things, right? The future and where it is going, how the industrial IoT is going to change it, the dynamics of it, was kind of confused a little bit as to, I didn't know if I should go fully low level, keep it very high level, probably into architectural, building blocks, things, and then rip it apart and start focusing on granular levels of IoT and sensors and thermal scannings and stuff, or kind of keep it at the cloud level or keep it at the database level. So there was a lot of confusion. I reached out to Sir and he said, keep it somewhere in the middle. That's what I've tried to do, but we can get any deep. The deeper you want me to go, I can go. The higher you want me to stay, I can stay. It all depends on what exactly you want to get out of the session. With that, let's make progress. So we're going to be talking about a few things here. We're going to talk about IoT fundamentals. We're going to talk about the key technologies. We're going to talk about some of the use cases that we're talking about the future, which is industrial IoT. We're going to talk about some considerations that you need to have if you're planning an IoT. Then we'll touch base a little bit on the future, and then we'll have hopefully some time for Q&A. But I don't think you should need to wait to the last for Q&A. You can stop me anytime. I'm not monitoring the chat. So if somebody is monitoring the chat, if you have questions, you can type it in. And maybe at the last, we can just run through the chat and find out if there are questions, and I'll try to answer it to the best of my ability. So we're going to be starting with what is an IoT. So the IoT, or the Internet of Things, and before that, some of you might not know who the hell I am. So let me try to see if I can say a little bit about myself. I didn't want to put this slide up, but then you never know. Sometimes people kind of start asking questions and stuff. So anyways, so I'm Prasad Balakrishnan, come from a very small town back in the 80s. Was born in a place called Packard, got my education in Pollachi. Spent most of my childhood in Pollachi. Started pretty small in 1991. Came into the political world of corporates. Just realized that I was kind of good in mathematics. I could understand problems very clearly. Once you have a decent understanding of maths, and if you can understand problems, then programming becomes very easy. So I was kind of a little bit okay in programming. Started working with customer information control systems, OS2 WARP, DB2, AS400, ES9000 systems. This was all in the 90s, which is possibly a time when, I think even now it is like that, communities and language were being decisive. And I decided, okay, this is probably not my world. Applied for a small company back then called Microsoft, and went to Microsoft. Was involved in Win 3.11 Win groups, got really, really good mentors who could train me properly, help me through understand complicated operating system definitions, kernel, driver programming, things like that. And moved into, from operating systems, started to get very boring. Nothing new was happening. I stopped learning, and then I said, okay, I have to go and learn something else. I shifted to video conferencing. Conferencing was becoming big because the first Gulf War started, and video conferencing was pretty big. The Iran-Iraq war was ending. US bombed Iraq, and there was a bunch of things that were happening back then. So went into Pitchatel. Today it's called Polycom. There was a massive coalition of companies that came together. CUCV Networks, First Virtual Communication, Rad Vision. I ended up creating a lot of patents there. Created video conferencing, created point-to-point conferencing, almost 6 different protocols, software MCUs, hardware MCUs, multi-conferencing units, switch controls, fabrics, a lot of things. Had a lot of fun between 96, I think 96, 97, all the way to 2004. And then video conferencing started to get boring. Audio conferencing was boring. There was nothing happening there. Or maybe I wanted to learn something more. Moved into hard drives, into Seagate. Changed my life forever. Because that technology, I've been in this Seagate for line of technology for 20 years now. I still don't even know 1% of it. I have more than 40, 45 patents, but I just don't know a lot of things there. Amazing technology on hard drives and how drives work and how air and physics and velocity. I mean, I could just learn a lot in the drive world. And then came down in 2004, created an enterprise called Zyotech in Hyderabad. Built it around $65 million, $70 million company, sold it back to Seagate, became the head of Seagate Flash. I ended up doing a lot of things on NVMe, onboard chips and semiconductors and things like that. And then Seagate HPC got acquired by Cray. I ran the entire Cray supercomputer thing. And then 2019, HPE got acquired. I mean, Cray got acquired by HPE. And then ever since I've been doing the HPC MCS, want to retire in 2025, maybe go to farming or maybe go to teaching. I don't know what I'm planning to do, but I'm at the last few years of my career. I just want to do something, maybe educate people, go at the lower grassroots or something, maybe to some tribal village and help them out. I don't know, something I want to do. That's precisely it. Married, I have 2 children. My elder one is a LLB graduate. My younger one is in 11th standard. He plays for the state of Karnataka. He's a cricket player. But I really don't know what he wants to do. He will do something, he'll figure it out. So that's pretty much it. Okay. So a little bit of a techie. I know a little bit of business. My current business is almost close to $3.7 billion per year turnover. I have 11,000 people in my team, and I'm doing okay, I think. That's pretty much it. Okay, so let's go to IoT. So what is IoT? The Internet of Things is a growing network of smart things other than the traditional computing devices, right? So whatever you see at your home, if you can actually control it from an app, and if you are able to basically make it go through a lot of things, then that is IoT. And it's an amazingly awesome device that can help you go through a lot of things, make life a little bit easier, and things like that. So why IoT? The fundamental line of why IoT is we are lazy, we are stupid, and we wanted things to happen without going and making it happen. So we wanted things to come to our place, and we tried to basically get it to work, and that's why IoT came. And the history of IoT was that there's this guy called Kevin Ashton in 1999 who was working for Procter & Gamble, supply chain automation. And the Procter & Gamble is the one that makes Vicks, a lot of other stuff that they make. Pretty big pharmaceutical company, around $60-70 billion in turnover, amazingly big guy. And these guys wanted to basically change the supply chain model. And there was this guy called Ashton who wanted to bring in IoT. And then he created a bunch of sensors, and he was able to basically transfer them into a digital data. So that's what he was trying to do. That right now in the world, there are around 20 billion connected devices. And by 2025, we're expecting around 85 billion devices. Whoever is writing on the screen, can you please stop doing that? There's an into mark there, a couple of yellow lines coming in. I would recommend that you do not use the whiteboard on Zoom. It kind of creates a bad impact for other people. And the unfortunate thing is, whatever you draw on the whiteboard is not going to go away for all the other slides. And that's going to be bad. So if you're using a mouse, do it outside. The main concept of smart devices was started in 1982 by Coca-Cola. And Carnegie Mellon University created their first ARPANET connected appliance. So in case you guys don't know ARPANET, 1952, somewhere after the Second World War, the United States basically opened up their internet to public. That at that time, it was basically called as the ARPANET, and where devices were being connected to each other. Code was basically being sent from one place to the other through wires and cables. And then the first Internet of Things basically started somewhere in 1985. And it's an integration of people, process, technology, with devices and sensors enabling remote monitoring, status manipulation, evaluation of trends such as devices. So basically, everything that you see around you in a factory, in a corporate, in your home, or anything is basically connected together. And you are able to basically connect it and operate it in one single integrated model. Is called the Internet of Things. The Internet of Things has now kind of diverged itself into individual devices. So you could have a fridge that you can control. Explosion of phone. In India today, an Amazon home is very much a dream come true. You can actually make it happen. My most recent construction was completely IoT based home. And there's a lot of value to it as long as you know what you're trying to do to it. But the main thing is to basically put a bunch of short range mobile transceivers into a lot of devices, and then you enable people and device to be communicating between themselves. That's the whole bottom line of IoT. So let's basically get into something called as the architecture of IoT. So very top level, you can basically say there are a lot of sensors, there's a lot of connectivity, there's data processing, and then there is the user interface. The whole bucket list is called as Internet of Things. It's called the infographic, right? So you have sensors, then you have connectivity. These sensors basically connect to your Wi-Fi or through 5G, 4G into your device, and it has got a backend bunch of servers that keep working on it. And then you have a user interface, which is on a PC or your mobile or any screen from where you can actually control it, is IoT. You can further subdivide that into a 5-layer architecture. The first layer is basically your sensors, which is perception. The second layer is your network, which is where all these data are consumed and then collated and then shared. Then you have the data processing layer, which is called as the middleware, where you have storage, you have analytics, you have actions, and then you have the application layer where you get to manage it. And once you do all those things comes the business. What do you do with this data? You get a lot of data. And what do you do with that? Once you get to the business layer, then you basically enhance your sensors, put it back to the circle. So it's kind of a rotating thing, right? So every time a new version comes out, you're going to have something better because of the analytics that was done based on the data that you were receiving. If you split it even deeper, so the application layer is smart homes, smart transport, smart buildings, healthcare, a lot of things. The middleware, you have predominantly Kubernetes and API interfaces that comes in. You have web services, Kafka, Elasticsearch, REST, you have JSONs. There's a lot of web services that come in. The big data centers, the big Oracle databases come into play. And then there's the cloud, which culminates all of these things, which becomes the middleware. The network layer is about your antennas, your internet, your routers, your Wi-Fi, your 4G, 5G, whatever. And then you have your sensing layer, which is about all the sensors that are connected on your device. If you basically go bottom up, that's how the whole IoT works. And on the right side, you actually see what's happening, right? You have sensors, you have a lot of smart devices, which all connect to a single gateway. The gateway connects to the cloud. The cloud basically sends it to a lot of control applications. There's a big data warehouse that basically goes in. And then there's a bunch of applications, business logic that connects to it. That's the entire IoT architecture. So the next few slides, what we plan to do is take each one of them and then try to basically get a little bit deeper to understand what each of these mean. So the 4-stage IoT solutions architecture, right? You have sensors, which are wired and wireless, and you find a lot of devices there, right? Your mixies, your grinders, your fans, your hospital lights, your devices, your car onboard dashboard, there's a lot of sensors that actually work. All of these things are connected to the internet gateway. And then in the gateway, you have Active Directory, your measurement controls, your data aggregation, all of those things comes in. Cisco, Aruba, Linksys, Netgear, D-Link, Samsung, Toshiba, Hitachi, HFCL, HPE play a predominantly big part in stage 2 and stage 3. In the stage 3, it's all about Wi-Fi, cellular, smart hubs, visualization ranges, which is basically connecting a bunch of these data through the internet, through various modes of transport communication protocols. And all of those things basically go back into the data center or the cloud. And there you have a bunch of mainframes, you have a bunch of supercomputers, you have a bunch of servers, blades, slingshots, which basically run through, process all these data, and then flip it back to the consumer. You could be in any part of this. You could be a sensor, you could be a gateway, you could be the edge, you could be at the data center. You're still part of the IoT world. To be very precisely clear, right? In today's modern world, every single living human being who is connected to any kind of device, be it a mobile phone, a smartwatch, or a Wi-Fi network, is invariably living on the edge. His data is outside. People have access to him. People know where he's going. People know what he's speaking. People can know what he's going to have food. What did he shop? Where did he purchase? Everything is out there on the edge computing. So based on the analytics that comes out of the edge, businesses are able to basically pinpoint their product to be made available to the consumer who wants it. And that's the power of IoT. The more IoT comes in, the more businesses will expand, the more people will get access to, the more laziness people will have. But eventually, the entire world is going to be one big IoT spectrum. And the power of the internet is phenomenal. Okay. So let's basically go into the components. You have sensors, you have connectivity. So sensors are nothing but the things in the Internet of Things. The sensors are the things. Then you have data processing analytics, which is connected over a network. So connectivity becomes the network. Data processing becomes the analytics, and the user management becomes the interface, right? And this whole thing is the fundamental building blocks of IoT. So what are sensors? Sensors are anything that are a key component that helps you connect live data from the surrounding environment. You could have an AC, you could have a thermometer, you could have a smartwatch, you could have an ECG system, and the complexities of these are humongous. If you have driven a car or a bike, You have a bunch of sensors that keep blinking: yellow light, green light, orange light, red light, all in your dashboard. Your phone has got battery sensors, antenna sensors. They're everywhere. Sensors are everywhere. You are even now have sensors built into your body. Pacemakers, data can be collected from a pacemaker. You have metallic arms for people with arthritis and stuff. You have a lot of different sensors which comes in so that they can commute on emotions. People who have lost their legs or hands can be made to be given an artificial hand, and they can basically be made to move their arms from remote. Even if they can't, their brains can send brain mapping waves to a device, and the device can help their hands to move. Even if they can't send the signal down, something else can send a signal to your arms, and you can start moving it. So these are the sensors and devices, right? So if you look at the screen, you'll kind of understand it a little better. So in the things, you're going to be having an ARM-based embedded operating system. So most of these operating systems are not based on Windows or Linux. They're all ARM-based. Then you have Node-RED, you have Windows IoT is there, Brillo is there. Brillo is an amazing operating system. So those are the embedded operating systems that comes on the things. And then you have the wireless protocols, which have Bluetooth, Wi-Fi, RAWAN, Sigfox, 3G, 4G, Threads, Sigwin. There's so many of these wireless protocols that you can use for communication. And then you have the analog signal chains, the sensors, the MCU, CPUs, wireless sensors, power management sensors. Most of them are triggered through semiconductors. And then you have resistors, capacitors, and all those things which basically trigger alerts. And then you have the RJ45, BNC, USB kind of connectors. So all kind of in a locked pattern. So those are the things. So the things are an embedded operating system inside it. They have a protocol to communicate to the operating system. They have modules which basically communicate to the protocols. And then there are resistors and stuff which basically connect to the modules. So the left side is all about things. So what is the connectivity? All the data, whatever is being captured, has to be sent to a cloud infrastructure. And the cloud uses a lot of different mediums of communication. Cloud is the most abused word in the industry today. Everyone has got a different meaning of a cloud, but that is a different thing. So anyways, you're going to be sending a lot of data up to the cloud, and then you're going to be having a lot of analytics basically going to be done. But the most important thing in today's world, as you all know, is communication. Zoom works on communication. The post-COVID world, everybody has learned to live remote and stay connected. And we spend more and more time basically spending time on things that we don't need, WhatsApp, internet, and things like that. But it has become an essential part of our life. Even school children need to have internet today to have a decent schooling. So the world has changed. And the communication boom created by Facebook, created by PointNext, created by GreenLake, they have taken the world by storm. Meta is the new word for Facebook. And I mean, the amount of satellites that those guys have put up in the sky is making communications better and better and better. The communication mediums include mobile, satellite networks, Bluetooth, Wi-Fi, WAN, LAN, MAN, a lot of different connectivity stuff. And without connectivity, there's no internet. And without internet, there is no embedded things. And so connectivity becomes the backbone of all of these things to work. In 1990s, Cisco used to basically say the internet is the computer. And people used to not understand what they're saying. And then they basically said the network is the computer. And then they basically stopped saying the computer. And now they just say Cisco is the network. That's it. And the network, if you don't have networks, you don't have anything. I mean, I'm talking to you because of my network with your director. So the network basically becomes very, very clear, right? So what happens in the network? And it just becomes more and more complicated, okay? You have application services, you have management services, you have gateway services, network services, then the sensor services, connectivity and network services. All of those things are connected in some way, shape or form. seamlessly making operations work. Let's take a simple example. You're connected from your Android telephone made by Samsung, connected on 3G, which connects into an RF signal, which is presented on some cell phone tower. And there is a digital transformation that happens to your analog model that comes in. The device modeling comes in. A bunch of your data is shared with the tower. Who you are, what's your SIM card, what is the call that you made, who did you talk to? Everything is basically recorded and kept on the tower and transmitted to various peoples who are basically monitoring you. So that is people tracking, the environmental is taking care. What happens, how does these signals connect to them when there is rain, there is excessive heat, there's excessive snow? Are you connected to retail? Are you connected to healthcare? Are you connected to transportation? What are you talking about? Why are you talking? What is the end result after you talk? Who are you talking to? What do they want? How did they talk to you? Everything is monitored. Everything is connected. And then the data flow security comes in. To make all these things happen, you have GSM, you have UMTS, LTE. LTE has got 6 different protocols. So one of those protocols comes in. Together, you end up seeing common things like Wi-Fi, Ethernet, gateways, access routers, and then you have a bunch of sensors which basically do it. So this whole thing is on the connectivity side of things. It's going to be pretty dry. So for a change, I'm going to be stopping now, and then I want to basically have some questions answered. So if you guys have questions, now is the time to ask me, and then we will go to the next set of things. If you don't have questions, you have not been listening. Okay. Your faculties, you guys should have questions. Yeah, Shankar, you have a question. Any questions? Anyone?
So there's a question from Amuda Ji.
Okay.
How to do real-time projects in IoT domain with low cost?
Why is cost coming into a IoT project? And I don't understand what is low cost. In my business, anything less than 600 millions is low cost. And I don't know what is low cost. So you can do millions of projects on IoT, millions and millions and millions of projects on IoT. Try to write an application which finds out who is sniffing what data from your phone. It doesn't take, it requires one Python, little bit of electrical knowledge, 100, 200 lines of source code. You'll probably make $1 billion if you can write that. Find out what information is going out of your cell phone without you knowing it. I think that most of the world will buy that application from you. It doesn't take a lot of time. And you can find a lot of open source which can do that. And you can track it down. And that is probably the best one that you can quickly write. I don't know if that answers your question. 200 lines of source code. Just write an application which finds out which information is going out of your phone and why. And you will be shocked to know how much data is being taken from your phone without you knowing it. what will be the security measures? We will get into securities in a while. Various sensors, it's everywhere, right? Every diode, every LED, every resistor, every capacitor. I mean, everything is a sensor, right? I mean, when you have fever, somebody goes and touches you. It's a heat sensor in your hand. So there's this lot of sensors. Edge computing with IoT. Edge has nothing to do with computing. Computing has nothing to do with IoT. IoT is different. Computing is different. Edge is different. Let's go back to the architectural diagram. So the problem is a lot of these marketing words come in, and then you really don't understand what is what. So if you look at, did I share my screen? I think I did. Let's see if I can share it. Okay. So if you look at this screen that I've shared, just give it a second. So you have sensors, actuators, wired, wireless, internet gateways. So those are all the sensor part of it. The computing happens in stage 4, right? Edge is in stage 3. So they are all different. Each one is a billion-dollar industry in itself, right? The people who make sensors are a different industry. The people who do communications are a different industry. Edge is a different industry. And data center is a different industry. Putting all these things together is IoT, right? So there's nothing called as edge computing. That's bullshit. Either you're on the edge and then computing is done by somebody else, or computing folks are not on the edge. You cannot be on the edge doing computing. The edge is all about getting the data. That's it. How do I get the data? Compute is what happens after you get the data, right? So that's edge computing with IoT. So in stage 3, edge IT, how will the pre-processing takes place? There's nothing called pre-processing. Everything that comes out of your system is put into a box, and it's split apart. A simple example will be Tirupati Undiyal. Gold will come in, diamond will come in, money will come in, dollar will come in, and then there are a bunch of people who sit here and start dividing that data, right? And that is all analytics and stuff. The pre-processing is basically creates a funnel that every data can just basically go and get dumped, and then you can basically split it apart. So that's edge. And edge requires massive compute power to funnel all these data seamlessly so that people don't get interrupted when their data is being stolen from their phone, right? You will be really shocked to know the amount of data that goes out of your device every single time you use it. And if every time it slows down, then you will start getting suspicious. So it has to happen without you even knowing what's happening. So that is edge. And there are industries which make $1 billion or more, like Facebook, like Google, who make $1 billion just taking information out of your system without you knowing it, right? So that's where it is. Anyway, so those are some interesting questions. Can you share resources to learn IoT from scratch? So that is Janardhan. Janardhan, it's called Google. Just open up Google and say IoT basics, and then you can get a lot of information. For you to master IoT, it will take you 50 years or more. You can probably scratch the surface. If there is somebody who calls himself an IoT expert, he's an idiot. He's lying, because IoT is the entire culmination of everything in the world of communications, telecommunications, internet communications, compute, data center, sensors. There's no one single human being who knows everything. Okay. Either he'll be a specialist in sensors, he'll be a specialist in networking, he might be a specialist in edge, he might be a specialist in data center, he might be an applications programmer on the cloud. So there is nothing called as an IoT expert. If there is somebody who says he's an IoT expert, he's an idiot and he's lying. In the image processing, in what aspect? This edge computing, edge cutting. In image processing has nothing to do with edge, right? Image is just a data, and then that processing has, to do with what you want to do with it, right? Do not confuse edge computing to image processing. Technologies are different. The use case of these technologies are different. The simplest way to learn computer science is not to complicate things, right? If you keep it split up, like how you went to school in first standard, science is separate, social science is separate, math is separate, English is separate, language is separate, which technically means together you are doing studies. That's it. You're doing schooling. Where is your son going? To school. What does he do in school? He's studying. What does he study? He studies English. He only studies English? No, he studies math. He only studies English and math? No, he studies science. So each are different. So as you split it further, you have physics, chemistry, and biology. In biology, you have zoology and botany. In chemistry, you have the chemical science of it, and then the biochemical science of it. In physics, you can go mathematical side of things, the analytical side of things, the environmental side of things. So you cannot combine everything and basically say image processing. So I should basically split the question, ask you back, what is a processor? Why is it processing? What is an image? Why is it called an image? Right? An image is a collection of pixels. Where do these pixels come from? And what pattern do they come from? Are they JPEG? Are they PNG? What are you going to do with this image? That what is processing? The image is different. So you kind of split all these things up, start looking at it simple, all of a sudden things become very easy. Okay. Let's keep going. Where were we? We finished sensors. Okay, let's go to data processing. Indira Gandhi, one of the greatest leaders in this country, a mentor for me. Thank you, madam. Okay, so let's basically go into data processing. So what is data processing? Once a data is collected at the edge, then it gets to the cloud. The software performs processing on a gathered data, right? And so what can be these data? It can be the set of contacts in your phone. It can be all the photographs and selfies that you took on your phone. It could be all the audio conversations that you had on your phone. It could be your AC data. It could be your environmental data. It could be a screenshot that was taken without you knowing it by your TV. It can be a lot of things, right? And once this data is collected, it is transmitted to the cloud through the internet. And then there is a backend software that basically starts performing some stuff on this. What do they do with this data, right? One, the data is sold to companies who are interested in knowing about you. In today's competitive world, companies really want to know, what are you going to do? If you're thinking of buying a diamond necklace, the company needs to know it much earlier so that they can prepare you in such a way that you will end up by coming to the store and buying something. So that's the world of targeted marketing, right? In other words, we call it as spear phishing. So phishing is information gathering. Spear phishing is targeted information gathering. So if I want to know what Indira Gandhi wants to buy tomorrow, I need to know it today. So that is targeted phishing. This process can be as simple as checking the temperature on your AC heater or something, and that can be really complex based on identifying objects, emotions, computer visions, or video. And today it's all going into that complex world. People are not interested, or companies are not interested in knowing the temperature of your AC inside your room. I mean, the ask is bigger. So much more deeper, what happens in the data processing layer. So it's a massive area. Okay, so in the data processing, if you are good in data processing, you need to understand protocols, completely different set of protocols. You need to understand security, you need to understand device management, how the sensors work, what kind of sensors work, what are the hardwares that comes into play, how do these hardwares work. So that's massive inside the data processing left side. Then comes the right side applications layer, which is even more easier, which is basically a web or your app, which is basically a catalog meant to point, click, understand what's going on, and you're done, right? Inside the applications layer, just below the layer that you see on the screen is the services layer, which is where most of the magic happens, right? What you see, what you click is not what the application actually does. The application has got resources catalog and message broker like RabbitMQ or Kafka kind of message brokers will be there, which are very light, thin, and you won't know what resources it's consuming. And that message can basically start brokering, right? And it does semantic meta store. So the data that's being sent out, even if you just happen to know it, you will not be able to read it because it's being sent out in a metadata format. And it's based on an algorithm called WAL, which is write ahead logging. So the log goes out and the write happens at the end destination. So what you do may not be the same way it goes out, but what you have done will be exactly the same thing that gets converted on the other end. And then you have simulation engines that basically run on it. Then you have a bunch of device connectors. So this whole thing is about data processing, right? It's an amazing field. If you're in computer science, if you know how to process data, the next 40, 50 years, you're going to be always having a job, definitely. It's just an amazing area called data processing. And then you have something called as the user interface. User interface is the thing that you see, which is extremely funny because you only see the top end of it, right? So you end up seeing a screen which basically shows your AC temperatures, an iWatch like this, which basically shows you a bunch of data that you can see, right? A lot of data is there. And you have a camera installed, a CCTV camera installed in your home. You get to see it on your application, things like that. So that's the end that you're seeing. What happens to the data behind it is where the magic is. Some examples of Internet of Things, simply speaking, a light bulb. Wipro has it. A lot of people have it, right? Which can be switched off or on using a smartphone. A child's toy, especially child who are deaf and dumb, or children with Down syndrome. You need to have a lot of sensors around them to understand what they are going to go. A dog collar, so that the dogs can identify your heartbeat and then react to it. A jet engine, your car. Today's modern cars, be it a 5 lakh, 6 lakh rupee car itself, has got more sensors and more semiconductors than the 1960s Apollo spacecraft. It's just phenomenal what this IoT has done to cars and your bikes and your in your homes and your mobile phones and stuff, right? And then you have things like aeroplanes and spacecraft, which has got a bunch of IoT things. So now devices that are coming out have got thousands of IoT components inside them. Each one is an amazing technology, but then they collect everything together and then they make a technology out of that. And it's amazing. Driverless truck, the new Tesla car that's coming out, the Google car, the Google Glass that's coming out, Apple AirPlay that's out there. Then you have Amazon Echo, Amazon Dot. Then you have the Apple TV. So there's a lot. It's just a collection of multiple different IoT components, right? So let's basically go outside of the basic and understand why is it important. Everyday appliances are kind of becoming problematic in our lives. So you have an OTG, you'll have a microwave, you have a gas stove, you have 4 burners, you have a gas cylinder, you have a regulator. I mean, how do you know if the regulator is going to go bad tomorrow morning? It will be amazing if the regulator can basically send you an alert saying, hey, I only have 2% gas left. You should book it now. So you are preparing for things to happen even before they actually happen. You can connect everyday objects, kitchen appliances, cars, thermostat, baby monitors, through the internet, right? I mean, nowadays you have 24/7 internet. Back in 1990, if somebody wanted to connect to the internet, they will have to possibly kill somebody or commit suicide, because there was a stupid thing called as a 56K modem. And then by the time it ended up connecting to BSNL, you almost jumped down and died. And the speed was pathetically slow. And then in low-cost computing, the cloud, big data analytics, and mobile technologies, they can collect with minimal human intervention. So it's extremely, extremely important. Remember, like all good things that science has done to us, every good thing can be used in a bad way. So science is not bad. Science is the only thing that keeps us moving forward. But for every good thing that science provides us, the human brain is so bad, it ends up doing it for a bad thing. But there are good things about IoT. Robotic surgery is one of them. Nowadays, with nuclear families, with children going away and working remote places, it's critical that grandparents get to see their grandchildren over a WhatsApp call. So the communications is extremely important. IoT is extremely, extremely important, right? How will you know if your grandfather living separately somewhere is actually going to get a heart attack? IoT can help you, right? So let's rewind IoT. So this is all that we talked. We talked about data, connected, smart, server, network systems, devices, business solution, mobile security. And if somebody is telling you that they know IoT, it only means that they know everything that is in the screen. Such a person is yet to be born. And if he's born, then he's not definitely answering to you, because he'll be dead by the time he ends up knowing all of these things. So they know the names of all of these things, right? For example, I don't know how a mobile works. I'm not an expert in a mobile. If somebody comes to me tomorrow and says, make me a mobile phone, I don't know. But I know the business of selling a mobile. I know the sensors that work in a mobile. I know how satellites work. I've worked for a lot of spacecrafts and satellites in my life. I know communications. I know storage. So the little bit of these things that I know. A lot of things I really don't know. If somebody wants me to make a security camera, I really don't know how to make a security camera. But I know if I get a camera, I can connect it and make it work. So there's nobody who knows everything about IoT. Okay, but in short, IoT is all about this, whatever you see on the screen. Anyways, I'll stop now. We have another 3-4 minutes of questions, and then we'll take it to the next level.
Hello.
Hi. You can type in your questions or you can ask it here.
Sir, participants can unmute their mic and ask the questions. Participants, you can please unmute your mic and you can ask the question to the research person.
Sir?
Yeah.
Sir, I'm Suresh Kumar from STC College.
Hello, sir.
2 slides you have shown that one is for example of IoT and another one is why it is important. But it shows both of the same thing.
Oh, it does? Okay.
So can you put it in one heading, sir?
Why? Okay, you said examples. Examples are not the same as this.
Oh, example, both are same.
They are same? No, they're not the same.
Example, you have told that cars, all those things.
So you're
The
not
same?
reading the slide. No, just read the slide. One is an example. The other
sir.
is the use of an example, right?
Yes, sir. No, sir. Why it is important?
So the last line.
Yeah.
Physical things can share and collect data with minimal human intervention. That's all.
Okay.
That is the only important thing of an IoT. That is the only use case of an IoT. Your data needs to be shared to someone so that they can make a decision for you. Correct? That's it.
Okay.
And that's it. If your device can speak, and you can make a better household. That's IoT. Simple.
Okay. Thank you. Thank you.
How the security is ensured. I'll get to that, man. We'll get into security. It's a big topic. Okay, so let's move. Key components, right? So we talked about sensors, then we're going to be talking about microcontrollers, and then we're talking about network connectivity. One of the big things that you will keep seeing again and again and again and again in this presentation is about how sensors are important, how microcontrollers are important, and how network connectivity is important. Because without this, there's no IoT. So we will take a lot of time to basically go through a lot of these things again and again and again. So sensors, microcontrollers, and network connectivity. So sensors are the things that collect information about your physical environment. Let's say, for example, your mother needs a cataract surgery. How do you know before your mother knows that she's going to require a cataract surgery? So keep them a mirror and they go and look at it. The mirror kind of analyzes her eyes, sends you an alert saying, you know what, her eyes are going to require surgery very soon. So your mirror becomes the IoT. Then you have microcontrollers, which provide the power, the computing power, memory, and the internet connectivity, right? There is no device in this planet today that exists without a microchip inside. And then for all these communications, you need network connectivity. People need to be connected. IoT has got some limitations because they expect things to be on the same Wi-Fi, but it's changing. In the next few years, you really don't need to worry about where it is being connected. As long as it is connected somewhere, you'll be able to basically reach to it. So what are the technology trends where this entire thing is traveling, which is the next thing, right? Trend number one, artificial intelligence. Artificial intelligence is only there because of IoT. Data is the fuel that powers IoT. So a lot of data that you require is required for you to enhance IoT. And artificial intelligence is the intelligence that is applied on that data to understand what it actually means. For example, let's say you want to buy a slipper. You're going into Amazon. How does Amazon actually know what kind of slipper you want? So they basically give you some examples and then you start clicking on a few things. They kind of understand how much time you're spending on that particular page, how many times you have clicked and zoomed a particular model. And then they try to do a profiling of you. And then the next time you go there, they'll take some more data. The next time you go, some more data. Eventually, they'll only start showing you things that you actually want. And your limit options kind of get reduced and reduced and reduced and reduced and reduced. But that is AI. One of my very, very good friends who runs NDTV, his son, Raj Kamat's son, Rajita Kamat, she's the one who is heading the AI division of spot marketing in Amazon. And she gets paid more than $1 million because she is able to predict precisely what is the next thing that you're going to buy. And that's amazing what she can do. So artificial intelligence is amazing. Then you have social, legal, ethical IoT. The word ethical has no meaning in a corporate. There is nothing called ethics in a corporate. Ethics is basic. It's called like ethical hacking. There's nothing called as ethical hacking. Hacking itself is smart programming. What is ethical hacking? What you're going to be hacking for a good cause. It's like a hero who will end up stealing from the rich. Stealing is wrong. I mean, steal from poor or steal from the rich. It's wrong. It's like that, right? Ethical IoT. Anyways, so the social, legal, and ethical side of things. So ownership of data, detections made from it, successful deployment of an IoT solution, demands that it's not technically effective, but all socially acceptable. There's nothing called as socially acceptable anymore. People get used to it. People are just okay with it. Nowadays, the amount of applications you download and install without reading on your phone shows how stupid people are when they use their mobile phone. Any link that is available on WhatsApp, people are just becoming PhD scholars by reading WhatsApp forward messages. They don't monitor, they don't analyze, they don't accept. Basically, you just become a bunch of WhatsApp idiots out there. And so there's people have just accepted to that norms, right? The trend number 3 is infonomics and data broking, which is the biggest happening in the world of economics today, right? Monetization of data. If you have data, how much money can you make out of that data is the one that companies are all behind. They want everybody to be on the edge, and then they want that data, and then they want to know how to make money out of that data. How to basically expand your business into strategic areas. How do you basically change your company accounts? IoT data is one of the biggest business happening in the world today. Every time you go to a Xerox store and you take a Xerox, what do you think is going to be happening to the data that is left over in that Canon printer? That data will be sold. They will have all data about everyone that has ever taken a particular Xerox, okay? So because these microchips inside it have got storage, they store it, and then that data is basically sold to somebody else for something else. And that is the biggest business happening on the planet today, monetization of data. Then comes the shift from intelligent edge to intelligent mesh. This is going into a little bit more complication. So edge is about a single device connected to an edge architecture, which is well within the confined IoT space. Mesh is about, you really don't know what network you're going to be connecting. You're only happy if your data gets sent across multiple networks. So that's more like a mesh, right? So that is a huge thing. Slingshots, Aruba, Cisco, Bot. There are a lot of companies, Bosch, Informatics. There's so many companies out there which are pushing intelligent mesh technologies out there. IoT governance, Aadhaar is one of them, is going to be amazingly big. Sensor innovation, sensors are going to be completely different after 2024, 2025, right? And the newer sensors, that some of the things that we are working in HPE, some of the works that IBM is doing, what Samsung is doing, it's just going to change the world in the way the devices are going to come up. It's going to be unbelievable. Operating systems, there are new systems coming out every day. Rocky has come out, it's phenomenal. A few days back, we had TOS coming out. TOS was unbelievable in terms of its embedded sphere. So Google, Chrome systems to TOS to Rocky systems, it's going to be phenomenal in the way of operating systems. So there's a huge explosion going to happen there. Then you have novel IoT. Novel IoT is new sensors, new algorithms, new experience, and new context, and then making it socially aware. So the user experience of IoT itself will change. Imagine you are basically walking through a mall, and all you end up seeing, and imagine you're like 100 people walking in a mall, 100 people see 100 different things in the same place. It's going to be phenomenal, isn't it? So that's going to be the new user experience. You get to see what you want to see. Your person next to you will get to see what he wants to see. You just need to wear intelligent glasses. And then you're going to have silicon chip innovations. You're going to have new wireless technologies. 6G and 5G are going to just explode it. 5G has already started coming into play in quite a few countries around the world. Silicon chip is going through ridiculous amount of transition in terms of power. Okay. And then we will get into a little bit of IoT use cases, and then we will stop for questioning. So again, do not use your whiteboard. If you go to the screen, all those yellow lines, the blue lines that you guys did are going to be hitting people, right? Do not do that. Okay, use cases, transportation and logistics are some of the use cases, right? For example, how do you track your courier? Where is it going? How long has it gone? What temperature is it being shipped at? Let's say you're shipping fish. How much time does the fish stay alive? How much time does it take for it before it starts, die, before it starts to decay? What's the temperature? What's the vibration? You have an elderly person in your car. How do you make the car avoid potholes on the road? How do you make the car drive on the same lane? All of these things are on transportation and logistics. And this is phenomenal what has happened, what IoT has done to cars, right? Autonomous vehicles. You don't know driving, you don't have a license, the car can drive by itself. Amazing. People, less cars. It's already there in the world today. They can drive by themselves. You don't need a driver. You don't need to know driving. They will go to the destination. Smart grid. Smart grid is basically electricity. Like entire of India is now going into a smart grid. Depending upon what you are consuming, the grid can decide how much electricity you are going to be needing. Instead of everybody getting the same amount of electricity, smart grids can basically make effective use of energy to be available, right? And then healthcare. Healthcare, you guys know, smart watches, smart shoes, smart biosensors, smart gloves, smart eyes, everything is smart nowadays, right? And they're just phenomenal. 25 years back, 30 years back, an open heart surgery was so complicated. Now keyhole surgeries have changed. So IoT and robotic surgery have just come to rule, right? Let's take a look at some products. Helmets. Smart helmets. What my son is using is also a smart helmet. It can basically tell you the temperature inside. It can tell you what kind of concussion it can hold. Connects to the watch, basically sends an information out. Kind of reads the speed at which the vehicle is going, gives an alert saying after this, if you're falling down, you're dead. Then you have robotic surgeries, you have fitness clothing that can basically increase your lifespan, smart running shoes, one button product purchases, click a button and then automatically everything takes care of it for you. It's called Amazon Dash. It kind of scans all the products in your home, what you have bought, and then automatically it can do a refill for you. You don't need to do a lot of things, right? Smart homes, smart gardens, smart television, smart devices, traffic controllers, and integrated violation cameras. You need a lot of them in India today. Traffic sense and India are two different ones, right? Anyways, so I'll stop here before we get into the future of IoT. And if you have questions, let's spend the next 10 minutes answering some questions.
Participants, if you have any questions, you can unmute your mic and you can ask the question to the research person. Thank you.
Sir, in what way Apple phone is providing a security than the other one?
If I know the answer, then I will be owning Apple. So Apple is not going to tell you that. But Apple doesn't let you install stupid software. The qualification for an application to be available on the Apple App Store is extremely rigid. They have a software kit that they will have to download. You have to pass all the test cases on it. You have to pay a filthy load of money to Apple App Store before you start hosting your applications onto the Apple provider. Every year, Apple is going to review your application from their end. If there are security breaches in it, your application will automatically be removed out of the thing. Every data sent outside of an Apple phone is encrypted, 100% encrypted. So that is also there. At least that is what Apple says. there are people like me who really don't use a lot of applications on my Apple. I live on my Apple, but I'm absolutely sure that my communications that are happening, be it WhatsApp or I don't use Facebook, I don't go to Instagram, I don't do any of those shit social media stuff. But my data is pretty secure. I'm in the industry. I know what people can do to your data, so I'm very secure on the internet. Apple claims that their phones are very secure for two reasons. One, you cannot download stupid software. Second, you cannot run pirated stuff on your Apple phone. Third, the devices, the type of NAND they are using, the type of protocols that they are using for their 4G and 5G are spectacularly secure. They use OpenSSL 1.1. I believe in the 14.3, they have even gone to 1.2. Their browser is pretty secure. Overall, the number of applications that drives Apple is also pretty secure. I wouldn't say Apple is also secure, but considering other products out there, Apple BlackBerry was very, very secure. And then the Indian government ensured that they did not want such a secure device, so they killed it. Apple is the next one, and government wants to know your data. And phones are trying to secure your data, so it's a challenge. To some extent, Apple is secure.
Hello.
Yeah, hi. Hold on. There's a question.
Am I audible,
from,
sir?
Yeah, you are audible, but hold on. Pooja, as IoT sense human brain activity and function. Oh, absolutely. Absolutely. Old people usually have a dog which can sense Alzheimer's, which can sense Down syndromes, things like that. And they have devices which transmit to dog collars, which are receptors, and then the dogs can basically react, right? You have brain mapping that is being made to understand why babies are crying or when a baby is going to cry. Mothers can prepare food for the babies much more smarter. If you are a mother, then you will know the pain of being a mother. You really don't know when your baby is going to wake up, when it's feeding time. Then there are smart doctors. Baby has got a heart problem. The baby has got an underdeveloped brain, or there is a cancer, or there is a traveling cell inside your body, and you can basically have a lot of things on IoT that can happen on brain mapping. I would basically say this. I think there is a YouTube channel called Simply Science or Simple Sense or something like that. And there's so many use case examples of brain mapping on IoTs. Phenomenal examples are there. Sorry, whoever was asking the question, I didn't mean to interrupt you. Go ahead.
This is Indra from GKM College of Engineering, sir.
Hi, Indra.
For me, one question that you told about the data analytics part and the predictions. Whether data analytics, sir, after mining, the analytics part is going on. Is there any related softwares after this prediction? The financial sector is using that any AI? I'm not aware of this, just to know the things I'm asking. The data prediction software, whether it gives any awareness for the financial trading people?
Oh, absolutely. Absolutely. What do you think our finance minister is doing? How does she know that by the end of this year, the tax collection is going to be lower, so all things need to be taxed at an extra high amount? How do you think she's knowing that? So there are prediction algorithms which are there. It's a simple algorithm that you write and then you keep innovating it. There are thousands of open source algorithms on finance which can predict trend patterns. But remember, that is illegal. Yes, on a finance market, you're not supposed to be using algorithms to understand where the market is going to go. The market is supposed to be unknown to everyone. So that gives equal thing. But if you actually follow the market, you should be able to basically write a small algorithm which understands predictions on how the market is going to behave. But yes, there are softwares out there which can do that. They are all illegal.
Is there any legal opening for this kind of activities in predictions? Just to share this same
millions of openings. Millions of openings. Okay. Just go to NYSE openings. I mean, any financial firm will mean, who doesn't want to hire a guy who knows where the market is going to go? I mean, I'll hire him for $1 million. I mean, the better thing is if somebody can write a software that understands what my wife is going to say next, I'll give him $10 million.
That's not possible, no, sir. Yeah,
No,
AI predictions cannot be also perfect.
They have not invented such a software. If somebody does it, he's going to be paid $10 million by every company, every human being. But no, that's not possible. But yes, there is a lot of opportunity.
Okay. Thank you, sir. Thank you.
You're welcome.
Good morning, sir.
Hi.
Yes, sir. Can you hear me, sir?
I can.
Sir, you said that data is being collected from the phones. It means that the data scraping is done, right, sir?
Yep, absolutely.
Then how ethical is this the data scraping?
Why did
sir?
you accept it? Before you install a software, you will say accept, accept, accept. You are the one who gave the rights. They are not doing anything unethical.
Okay.
They have told you that I will be collecting all this data, and you said, okay, they are collecting it. Nobody asked you to install it, right?
Okay.
நம்மளா போய் விழுந்துட வேண்டியது அவன் என்ன தள்ளி விட்டாங்கிறது ஓகே அதுல எங்க எத்திக்ஸ் வரும் நம்ம படிக்கிறதே இல்லையே நம்ம படிச்சவங்க கையெழுத்து போட மட்டும் தானே ஓகே
but then this ethical hacking is now like it is evolving.
What is ethical hacking, Amma? It is basically saying I'm eve teasing somebody because I know that girl. It is still wrong. What is ethical hacking? It's still wrong. If I know you, I cannot eve tease you, right? If I don't know you, also I should not eve tease you. Simple.
Okay.
தெரிஞ்ச பொண்ணுனா கிண்டல் பண்ணலாம், தெரியாத பொண்ணுனா கிண்டல் பண்றது தப்புங்கறோம். அது எப்படி? கிண்டல் பண்றதே தப்பு, அவ்வளவுதான்.
Yeah.
அவ்வளவுதான்.
Okay, sir. Yes, sir.
Any other questions? Okay, so we are coming into the last half an hour and we'll see how much we can go. So where is the future going, right? Industrial IoT, which is where it's already gone. The Industry 4.0 spec basically pushes industries to connect the physical and digital worlds to transform the manufacturing process, improve business operations, and drive the revenue growth. Industry 4.0 would not be possible without the industrial IoT. I would recommend that you basically go to the web and start reading about industrial IoT. It is going to be the future, okay? And it is basically going to be taking IoT to a completely different level, where the industries are going to be using IoT to enhance safety, change maintenance programs, improve operational efficiency, enable operators to be more effective, and reduce unplanned downtime. So that is where IoT is going to go next. And then technicians and specialists can change the pattern in which they work. You don't need to be a specialist available 24/7. You just need to predict when the specialist is required, only employ him at that particular time. So you can reduce his travel, you can reduce the footprint of money that you're going to be spending on him. On the manufacturing floor, you can change the quality of manufactured goods on the fly, change the production process itself. All of these things are basically done with IoT. Sensors, which can adapt to different changes that are happening on your machine and then behave differently, are also a good thing that is going to be happening. The whole thing is about prediction of maintenance and prediction of service and prediction of what's going to happen next. So as long as the equipment downtime is reduced, the maintenance schedules are reduced, the profit actually goes up. So industrial IoT is going to be the future. So what are the 5 different ways companies are using augmented reality? Guided assembly. So robotics has come into play, and that is totally because of IoT, right? Training. How do you get to train people based on what they want? How do you change the behavior of training? How do you basically change the mobile devices? How do you reduce the number of teachers in classrooms? Are all because of IoT. Remote maintenance and repair, trying to fix something that is broken inside your home without them coming to your home, or in a manufacturing plant, or basically trying to do a surgery. A doctor is in Bombay doing a surgery in New York. It's all IoT. And robotic surgery. Doctor doesn't need to be there. He just controls something and he does the job. Quality assurance, on augmented reality, right? It helps you to bring engineers and operators quickly to an output for a design spec, verify the right parts, take care of logistics, industrial facilities, a live video feed basically tells you how to do it. I was recently in with an NGO, and I went to a prison, and I was able to actually, not in India, outside of India, but was able to observe how they do security enhancements, and it was phenomenal. This was around a couple of years back. Phenomenal what IoT was able to do. Okay, we go into IoT considerations. If you want to do an IoT project, small, medium, big, doesn't matter. There are 6 things that you want to be very, very careful on. Privacy and security, the first and the most important one. Interoperability, hosting, data connectivity, incorrect data capture, and then scalability. We're going to be looking at each of them, right? Let's first go into privacy and security. As I know a lot of questions were asked on security, right? What are the most important security issues that are being faced by IoT? One is attack surface. With more and more physical devices being attached to the internet, the entry points for attackers are many. It's actually infinite now. So how do you actually prevent them is the bigger thing, right? The proliferation and ubiquity of these devices in the enterprise would be attackers, more chances to eventually access a company's broader security architecture. So most of the corporates, we kind of train our employees on what not to do. The firewalls are becoming stricter and stricter and stricter. Many companies do not allow personal laptops. Bring your own device. It's no longer approved. You have to work on company devices. You have to use very secure VPNs to connect to the company from remote. If there is no authentication, there is no data available. And the authentication basically goes into 4 or 5 levels nowadays. Data privacy and protection becomes very, very important. People need to know what they are storing on their phone and what they're going to be using with it. Same in a company or corporate laptop. Many applications collect confidential and proprietary data and then they transmit it outside. If they do not have authentication, they are very easy to exploit. So, my simpler thing is always have authentication. If there is no encryption, do not send data out. Botnet is poor. If an device itself is poorly safeguarded, then you have something called as a botnet requirement. It impairs the performance of the device itself, and then it brings a lot of harm and reputation in the long term. And then attacks from extended outside on the process itself, right? People are bad and they will want to disrupt a business. And the easier way to get access to the business is through a device which is connected to the business. And then they basically do a DDoS, which is denial of service. And then once the denial of service happens, then you are not able to connect to that particular service. They're not able to do it. So all of those things require extreme secure infrastructure that needs to be created. So what are the things that there are tools to fix all of these things, right? So you have cloud security, data security, cyber security, social security, penetration testing, cryptography, sniffing, footprinting. I mean, it's humongous. The amount of security trainings that I have gone through in the last 5 years is probably more than that I've ever studied in the past 20 years, right? It's phenomenal amount of security stuff that is happening out there. Edge computing can be dangerous. Then comes interoperability. Interoperability is you have multiple different devices connected to multiple different protocols and multiple different networks, and the data center is not defined. How will you define a data center depending upon what phone a customer is going to buy? So that is different, right? So interoperability becomes a big thing, right? Operating system compatibility for an application becomes extremely important for the application to be successful. Your cloud needs to be flawless in its execution. Whoever leads an IoT project needs to check a bunch of interoperability standards. If you're running your cloud on a 4G and your devices are all on 2G, if they cannot communicate to each other, then what's the big deal, right? What's the point? So you need to basically have IoT experts going through a lot of interoperability standards. The third thing that you need to basically look at is the hosting. Hosting is the cloud, right? Where do you get to host it? You can create your own cloud, and then there is a lot of security and troubles that you can come because of that. Instead, you basically go and host it in one of these mega guys who do IoT platforms: Amazon, Microsoft, IBM, Google, HPE, Oracle, Cisco, Salesforce, Bosch, Cisco IoT, SAP. So there are a bunch of these guys who do hosting for you. They're not cheap, but they're very secure. They're quick to operate. You can write your app, connect it to Amazon Web Services, you're done. And a lot of these things are done with existing infrastructure. And these companies make billions of dollars giving infrastructure as a service, which is another big industry that is booming because of IoT. It's called as a service, anything as a service. In that, IaaS, which is infrastructure as a service, is one of the biggest growing trends in the industry today. HP GreenLake made 14 billion last year. Connectivity, data connectivity is very improved. A lot of packet radio services, GPRS, Wi-Fi LANs are there. There's still telemetry data that are being sent out, which are not compatible. So right now, the world is looking for a common edge platform that everybody can integrate into. But that common is a tricky word, because if it is common, then people will exploit it. So it's actually a trade-off between making it easier or making it complex, right? So there's always a middle ground. You try to find a combination of transport and data ahead of the deployment. And then you figure it out in such a way to understand who is your consumer, who is your database, who is your backend, and then you try to basically architect it for that combination. You just cannot write something that serves everything in this planet. The last one is connectivity. In IoT connectivity, some of the important things are power, right? What's the range? How big needs to be your Wi-Fi? How many rooms are there? What are the black spots? Is it easy to configure it? Is it easy to deploy it? Can it go through multiple different operational challenges? Heat, cold, humidity, rain. How secure is my wireless? What kind of encryption do I use? Do I use web? Do we use WAP and web? Do I use a 512-bit encryption? Do I use a terabyte encryption? How does it align to my PCs, my phones, and data privacy strategy? So all of those things basically come in the IoT connectivity world. Then comes the stupid thing that people can do. You take the wrong data. You really don't collect the data that you want. Instead, you try to collect data that is not needed for you. A business is least interested in any of your photographs. What will they do with your photograph? The business doesn't want it. They want to know more about what you're trying to do. And so you end up losing billions of dollars if you collect the incorrect data. So you got to be very clear on what data you want to collect, be very precise in how you collect it, how you structure it, how you process it, and then what do you do with that after that, right? Bad decisions can lead to bad money being spent. So what are the challenges there in bad data capture? Data diversity. India's got what, 187 languages, 27 official languages, 97 script languages, and every operating system is now supporting 10 to 12 different languages. So communication of data becomes very important. It's diverse. The quality, some are on 2G, some are on 4G, some are on 3G. Some don't know what they are doing. They just download every WhatsApp video and start looking into it without even knowing if that video is a JPEG or it's an MP4 or an MB3 or an MB4 or an MP4. Protocols can do a lot of harm to your system. So before you download, make sure that you understand what you're downloading. They're noisy, the quality is different, and then it can probably cause problems. Real-time data. Nowadays, you have the world of Netflix. There's streams which are pumping in huge volumes of data, and you got to basically process it real-time. Systems need to become better. Your backend needs to be better, and then IoT becomes smarter, right? Netflix and Amazon, I think, pretty good job on understanding what kind of movies you want to watch, and they make their business purchases based on your IoT. Time and location. Don't send an ad to a person when he's not there. What's the point of it? He has to be online. Only then you basically send him a targeted ad. And then do not send a culturally sensitive ad to a person who is culturally stuck. Cybersecurity. Make sure that it's a mandatory thing to safeguard the data at the client side, at the middleware, and at the server side. It's extremely critical. So when you're trying to basically do an IoT analytics platform for your college or by your student or for yourself, make sure that you're doing it in a dynamic and intelligent way, that it is able to predict and make proactive decisions. Do not make a IoT platform that is historical. IoT is all about prediction for tomorrow. Make sure that you can widely distribute that data across multiple different things. Learn about ZFS, learn about Oracle parallel storage, learn about the Lustre, how to basically create a platform that can do distributed storage. D-RAIDs, D-RAID 1, ZFS 1, ZPool 1. There are a lot of RAID algorithms that can help you to basically distribute data very, very safely. Scalability, you got to basically scale it, right? Imagine when you're writing an app or you're going to be making an IoT device, you don't write it for one person, you've got to write it for billions of people. And so make sure that you are able to scale it. Make sure that you can change on it on real time. Ability to basically go and change the way the app is behaving should be real time. Whoever is talking, please mute, it's disturbing. Interoperability. The platform should provide interoperability between different IoT infrastructures. You should be able to basically communicate from your Amazon platform to a Microsoft platform to a HP platform, and make sure that your security is really, really good. Okay. So if you are writing to do an IoT application, then make sure that your platform has all these 6 points. Last few slides, and then we are done. IoT scalability. How do you scale the IoT, right? Large wireless systems, simplified network planning. I mean, network planning is an ocean. Interoperable architecture, an architecture that connects different layers, remote network and device management, and scalable software infrastructure. These are the essential things about scalability. Each of these slides, guys, each one of these 50 slides is a PhD material. Take one slide and you can do a PhD on it. Okay. Why is scalability important? Scalability in IoT is the scale key because it helps you to prevent project failures. If an IoT project is a failure, the amount that you have spent on it in terms of infrastructure, money, effectiveness is humongous. But the failure of a project is a high possibility because you really don't know how it is going to come up, right? Because there's not one single company who knows everything about what is happening on the IoT world, and they make a lot of mistakes. There's no IoT specialist company out there on this planet. Some are good in sensors, some are good in backend, some are good in the cloud, some are good in the connectivity. So you really don't have a champion across this board. Why are there issues? Lack of planning. You just start doing a project without planning. There is no POC, and that causes a lot of problems. You really don't know what the future devices are going to be. IoT devices will reach around 84 or 85 billion in the next 2 years. Now we are at 25 billion. So it's going to be exploding by 2024. COVID has accelerated IoT. And how will you write a software that is going to be compatible to devices coming in the next 2 years? Then budget. If you are going to be writing something that is going to be supported by every single device out there, it is also going to be practically a very, very, very difficult thing. So keep an eye out on that. So some disclaimer. Most experts will basically tell you, right? It will take you a few months to learn the system. That's wrong. I've been in this industry for more than 30 years, and I can tell you that I know less than 1% in computer science and communication sciences. Less than 1%. So it's an ocean, and I know little bit of it. I know the ocean has water. The ocean has got some fish. The ocean has some bad things, and there are boats on the ocean. I really don't know anything more than that. That's it. And there are people who know about all the fishes in the ocean. There are people who know about all the arthropods in the ocean. There are people who know about all the salt content in the ocean. And there are different specializations. But mastering IoT is a lifelong journey. Somebody can do it. Good luck for them. I do not have that capability. Actually, after 60, 70 patents in my name, I still think I don't know anything in computer science. I really don't know. The new children can beat me in things that I took a lot of time to figure out. I think the new children can beat me just like that. So I'm absolutely sure that I don't know a lot in computer science. What about the future? Emerging technologies will make IoT better, right? Cloud computing, big data, AI, ML, blockchain, digital twin, all of these things are going to be spectacularly good for IoT. The bigger things basically comes in 5G and 6G. But is it really safe? There are these pundits, environmental pundits, right? Will come and say, oh, it's not going to be good for our planet and all these things. So I really don't know. I'm not a geologist. I don't really know. I'm not a WhatsApp professor. So I really don't know how to say what is spoiling our planet. But if you look at the good things about the IoT, there's a lot of promise that it holds. The lesser carbon we emit, the better the world is going to be. If I can understand what kind of room and environment that I'm in, if I can shut down my AC, then I am, using lesser fossil fuels, lesser carbon emissions. Maybe the technology can help us make a better world. But I'm not an expert there. I wouldn't know. AI is really good. Then there are people who basically say AI is going to control human race. I don't know. My wife is controlling me, so I think AI was first invented when man got married the very first time. So I really don't know about AI. The emerging technologies will have cloud computing, big data, artificial intelligence, machine learning. They are spectacular technologies. And they're going to make the world a much better place to live in. Will there be only good out of it? No. I mean, human race has always had good and bad in everything that we have done. And the only thing that you can do is very simple steps, which I'm pretty sure most of you do not follow. Don't buy pirated software. Your operating system has to be legal, legitimate. Your software has to be legal and legitimate. Do not surf dark web, untrusted porn sites. Do not go there. Have a really good paid anti-malware, adware, antivirus, and make sure that your browser is extremely secure. Do not buy, share, download pirated or torrent-based software, audio, or video. Ensure that your phone is encrypted. If you don't know, talk to your provider. Do not visit sites where you share data that are not using SSL. Check or do not click on random links read about phishing, spear phishing, smear phishing. Be safe when you do video calling. Be safe when you're doing audio calling. Keep your cameras closed with a flip screen or a paper when you're not using it. Do not download any software without understanding what data you're going to share with the content creator. Do not accept it, just install it because you want to use it. Read. There are really, really good softwares out there which do not collect data, but they do not market it. So you'll have to go and find out what is the best thing that you want and install it. I think App Store has got 73 billion applications. Your phone has got like 20. In 73 billion, you should be able to find the best 20. Read before you accept terms and conditions. That's the most important thing, which I find absolutely lacking in today's educated people. Being educated means you are educated, which means you are able to read and then understand what you have read. Without reading, if you click on the accept button, you're the biggest idiot. You require your data to be stolen. When in doubt, stop the first time and every time. If you're having a doubt, why install it in the first place? And then just be safe. Enjoy the world of IoT safely and secure. And Q&A. So we are on time. Another 15, 20 minutes of questions. Happy to answer anything that you have. You can ask any questions that you might have.
Any questions?
Yeah.
Anybody have questions? Thank you, Prasad, sir.
Yes, somebody had a question.
Okay.
Good morning, sir. Sir, is there any study done for the reliability and dependability of these IoT systems?
Oh, absolutely. There are IEEE portfolios, there are forums which basically do this, madam. There's a lot out there. Just go to IETF and you will find so many specifications on regulatory authorities who basically do all these. There's so many of them.
Okay.
I mean, the governments are going to become very, very, very strict very, very soon. People now know that people are losing data. And soon people will know that they have lost their identity. And then they will realize that they have been stupid. And then they'll complain. So there are regulatory bodies coming in. Hopefully it will come sooner. But nothing happens soon in a government, right?
Yes. Okay. Thank you, sir. Thank you so much.
Yeah. We still have 13 minutes, I think. Any questions if you guys have? I'm happy to answer.
So we will get the recorded videos or not?
Yeah, actually, this is a recorded session, and live session is telecasting in our YouTube channel. I will share the YouTube link in our chat.
Okay. Kindly upload the session to YouTube. I don't do that, but your college is free to do that. I have a separate forum, IETF, where I do talk a lot about technologies and trends and some of my patents, but that's on the international, the engineering task force side of things. I am not a good professor or a lecturer like you guys, so தெரியாத பண்ணக்கூடாது. அதனால நான் அந்த இடத்துக்கு போறேன்.
Anybody have a question?
So let me wind it up, right? If I, there's a lot of information. Sometimes it's difficult to consume a lot of these things in one set. Ideally, way to do this is to take one of these slides and then one box in one of these slides and then do a technical session on that. That's how you become a technologist. Technology is the only thing that I know. I can cook really good, but outside of that, the only thing I know is technology, and it's a passion. What this younger generation is, what this younger generation is capable of.
இவர் முடிச்சோம் இல்ல அவர் தனியா பண்ணிக்கிறாரு, மாடரேட்டர் தனியா பண்ணிக்கிறாரு. இப்ப இவர் முடிச்சாருன்னா அவார்ட் ஆஃப்னு சொல்லிருக்கேன்.
Okay. So if I can do justice to whatever you're trying to search in this forum, I'm thank you. I'm really thankful for an opportunity given to me to talk to learned people like you. Hopefully in the due course of time, if I ever get an opportunity to meet you, it will be really good. In the meantime, if you have questions or comments or concerns or anything, just route it through the college. I'll be able to get it. You can directly reach me at prasad.balakrishnan@hpe.com. Or just go to my LinkedIn profile and you should be able to find my coordinates and you can do a connection there as well. To all you people out there, be safe, get vaccinated, stop COVID. It's in everybody's hands. Be safe on the internet, and hopefully you can create a device which is going to transform the industry to the next level. And at least as technologists, it's our obligation to basically give it back to science, what science has given us. I have done a little bit of contribution to science. If each one of us contribute to science, it will be a better world for our grandchildren tomorrow, hopefully. Okay. I wish you all well. Thank you, Director Sir, for giving me an opportunity.
Thank you so much, Prasad Sir, for spending your valuable time with us. Yeah, amidst of your very busy schedule. I already came to know about this, and we are also very thankful to you for accepting our invitation in my person. So personally, I would like to thank you. So probably the emoji as well as the moderator will also have a separate session for vote of thanks.
Thank you.
Thank you, Prasad Sir. Thank you, Director Sir. I think nobody have questions, so we can conclude our session. We have come to flag end of our program. I thank Mr.Prasad Balakrishnan for accepting our invitation and enlightening us on future of IoT. I extend heartfelt thanks to our management, principal, and the director of School of Computing Science for supporting and guiding us. I thank faculty members and external participants for their active support and participation. Once again, thank you so much for attending this session. We will meet again tomorrow morning with another topic. Thank you so much.
Thanks, guys.
Dear participants, please wait. The feedback form is posting now. We would like to have your feedback on each and every day. At the end of the session, we will give you the feedback form. And this will also be considered in order to qualify for your certification. So please kindly do that. Thank you.
A feedback form is already shared on our chat box, so everybody can fill that form through that link. Any doubt regarding feedback form?
We will conclude this session with a formal vote of thanks. Thanksgiving makes a sense. I would like to thank this. I'd like to take this opportunity to thank each and everyone who made this day event, a great success. First and foremost, I extend my gratitude to our resource person, Mr. Prasad Balakrishnan, for sharing your knowledge in IoT, which makes us go deeper in IoT. Thank you, sir. I would like to thank our director, Dr. A. Abdul Rasid, for granting this opportunity. Thank you, sir. I thank our technical team, moderators, and each and everyone who made this day event a successful one. Finally, I thank all our participants who participated and gained knowledge. Thank you, each and everyone. All the participants, we look forward for your kind cooperation for forthcoming FTP days. Thank you, each and everyone. Your feedback link will be posted in the WhatsApp group also. It will be activated only for 15 minutes. So kindly fill the feedback immediately. Thank you all. The same link will be for all the FTPs. You can use this link for all the forthcoming days. Thank you. Dear participants, kindly fill both the feedback links. We have floated 2 links and you are requested to fill both. Participants, you can leave the meet.
You can leave the meet after filling your feedback forms.